Hello everyone, this is Reza. Welcome to another video of Intermediate Rigging series. In this video, we're going to produce a new skin chain using our current character skeleton. Now, we have so many extra nodes and constraint on the current skeleton, it's certainly going to slow down the scene if we have another skin bind on top of everything else. And that's why we need a fresh, clean new skeleton just for binding process. The new skeleton needs to have the same orientation as every single joint in this scene, and it needs to follow the control setup that we created. So for example, if I lift the foot control, the new skeleton should follow. While you may think it's going to be a long session, it's actually relatively easy to create this setup using Python scripting. And that's what we're going to do today. As a matter of fact, you can manually set that skeleton up. It just takes time. The way you do it is you create joints, you parent it to each bone to get the same orientation, and then you delete the constraint. You need to name the bone and then reparent it so it follows the main bone using a simple parent constraint with no maintain offset. But again, to have that done on every single bone is the part that can be very cumbersome and time consuming. And that's why we are going to use Python scripting to our advantage to expedite the process. Now, let's see how we can make use of that. I'm just going to go and clear our history in here. Now let's set up our new chain. So I'm just going to call new chain and import the commands and use ls to return the names of objects in the scene. One of the flags I use every time I use ls is actually sl equal to 1, and sl lists objects that are currently selected. We are going to select a number of joints, so we need that to be true or set to 1. The type of objects we are going to collect or select rather, we want to specify that too. It's going to be joints. Get that one fixed. Let's create our for loop. And if you don't know what a for loop is, it's used for iterations over a sequence usually. It's got so many functions such as range or else, but what we're going to use is going to be fairly simple. So let's go for object in, and again we are going to use this guy. So we're going to say whatever we select, and we select the new chain, but whatever happens, go through all the selections and do the main thing, and we are going to define that very soon. So obviously we are going to use the right index. So cmds select clear set to 1. So we want to clear the selection first because we don't want anything to be selected when we set up the parent constraints, so on and so forth. I'm going to then define a new joint, cmds joint, and for the name, again, you can go with pretty much any name that you want, but I am going to follow the naming convention that I've had throughout the series. So what I can do, I can just maintain the original bone name, follow this by skin. So we just have a suffix skin to be added to our hierarchy. And then we're going to create parent constraint. That parent constraint is necessary when you create the joint. You need to use parent constraints so the newly created joint has the same orientation as your original chain. So we're going to create the parent constraint, CMDS, and then parent constraint with capital C. Then we select OBJ, the new joint, and do the parent constraint with maintain offset set to 0. So basically the new joint snaps to the original joint with the right orientation. Once that's done, we don't need the parent constraint anymore, so we can just delete that. I'm going to copy and paste the name so there is no typo, since I'm pretty good at making mistakes and having typos in my codes. Of course, every time we orient a joint or rotate it to bring it to the correct position, we always want to freeze transformation on it. So CMDS, make identity, which is freeze transform in Python. We are going to freeze transform our new joint and apply that. So apply equals 1. Now we would like to apply another parent constraint. So we can say CMDS and parent constraint, and this is for the original joint to move the newly created joint. We can say we established driver and driven, of course, object, comma, new joint, and again maintain offset set to 0. We don't need maintain offset because we established that here. We already have the same orientation, so we really don't need to maintain any offset here. Now we forgot to give this a name, the new parent constraint. So this one was named P constraint. We can just name this one P constraint 2. Really, it can be anything, but I would like to have just a clue of what that name is about, and that's why we put P and constraint, so we know it's a constraint and the type is parent. Now this really should do the job. I'm just gonna create 2 lists so I can select. One is going to be JNTS for joints, and the other one is going to be constraint for my constraint. In case if I want to select joints or constraints, I can do that easily. So in here I can say JNTS, then append, and of course I'm going to use the new joints that we created, so new joints, and then this constraint that we just created, append to the new parent constraint that we created. Now let's put that script to a test. You can just pause the video, check everything, and then we can go ahead. So let's put that to a test and see what we're getting. This means that if I go and select something, and that something, remember the type is joint, I can just do a for loop, and that for loop goes through every single selection and will run these commands. So with those selected, I'm going to select everything and go execute. Now I have 3 joints with constraint, and the beauty of these joints is they follow the orientation of the original. They have the right naming convention. So for example, if I select one of the foot controls and move, you can see the newly created skin chain follows beautifully with the same orientation, and that enables us to just hide the old skeleton for control setup, reserve it for control setup and for parent constraints and for moving the controls and leave this fresh chain and reserve it just for skinning purposes. Another benefit to this is you can actually bake the animation on this skeleton, this skin hierarchy, and then later on export it to a game engine if you want to. So there are a lot of benefits to this setup. Now we know that our script is working. Let's just add one more line, and that enables us to select our lists that we created. So it's JNTS. So every time we want to select them, select only the joints but not the constraint, we can. So if I just if I expand all of these and only run this line, I'm going to deselect everything so you guys have a look at what's going to happen in the outliner. If I only select this line and right click and execute, it only selects the joints. That is really cool. So first step is done. You feel free to pause the video and finish the script. In the next step, we are going to go through the hierarchy and we are going to select the joints and bones that we need for our skin skeleton. And then we are going to apply this script on it. We parent everything, and after that we have a nice, fresh, clean skin skeleton that properly follows the original, or rather old, character skeleton. Alright, hopefully you've been following along, and if you have, then everything should be nice and clean within this global control here. So all the bones and every control should be found under only one group and one group only. Now the skeleton that we're targeting should be under center of gravity. So if I click away to deselect and select CTRL COGRP01, you can see everything is selected. The rest, we're talking reverse foot chain, obviously we don't need that, and also flip joints, we don't need that either. So if I go here, I can start selecting all the bones one by one. The ones I want to exclude would be shoulder joint and elbow joint, simply because I have the same joint advanced twist chain with the same orientation, so I don't want to double up. I also don't want to include handle ABC for the spine, simply because I am going to include every single spine joint that I have, and they will get moved by the handle A, B, and C later on, so I don't need those. Also, feel free not to include the end joints, all the D ones in the finger, simply because they're not going to have any influence on any vertices. I am going to include them in this tutorial, but later on I'm going to remove influence on all the end joints. I don't need them to derive or have any influence on any points on the character. With that said, let's go ahead and select the skeleton one by one. I'm going to reference or template the character rather, so I'm not going to select the geometry by accident. I'm going to zoom in so I know that the bone or the joint that I'm selecting is correct. So I'm going to select the helper for the bat, and then helper bone for the back, and a helper bone for the knife, and later on I can just simply parent them to the chest bone. Then I'm going to scroll down. I can do the same thing, have the bottle, and going down I can have toe, ball, ankle, knee, and thigh. And since I'm selecting thigh, then I really don't need to select JNT leg connection 01. I also don't need to include flip joints as well. I'm going to do the same thing for the other side. I am going to select toe, ball, ankle, knee, and thigh. Then I'm going to move forward with some of the helper bones. Again, this helper bone later on will be parented to the thigh chain again when we make the connections. Doing the same thing for the other helper bone, which is arrow pocket. Now a spine, I am going to include pretty much everything, and it starts from the eyes. So I'm going to go ahead and select the end eye joint for the right hand side, and then a right eye bone, left eye joints, left eye bone, JNTE head. Again, it's one of those bones that you probably want to exclude. I'm going to include and then remove influence. After that, then head, neck, and base of the neck. That, well, basically the head bone and the neck bone will get parented to the base. And then from there, it goes to the spine. So it goes to spine one by one. Again, I try not to include the handles. And then I'm going to select the clavicle. I'm going to leave shoulder and elbow and go straight to wrist, thumb, and then go to fingers and select all of them one by one. So if I go here, I'm going to do the same thing for the ring. Scroll down, do the same thing for the pinky, and of course for elbow twist. We want to include elbow twist and shoulder twist, and that's why we didn't select elbow and shoulder. Definitely not to include IK and FK, they're hidden, we're not supposed to even touch them. So moving on to the other side, and I'm going to select shoulder twist and clavicle. Again, we leave elbow and shoulder behind, and we continue with the wrist and left thumb, left index. We continue with left middle, left ring finger, and left pinky. We're going to continue. I'm going to include elbow twist. We're going to leave LIK, LFK, and include shoulder twists, and that really should do it. Now, the easy part, I'm going to bring the script, right click, and execute. Now, to see the bones, all I need to do is to collapse global control, and then I have a long list of joints that I need to parent, and they all come with parent constraint, and they all have clean rotation values because we did freeze transform on all of them. Now to see them better, I'm going to select CTRL global and press H to hide them. Also, I'm going to select all the joints, probably reduce the radius to something like 0.4. And all I need to do is to go to each one of them one by one and just establish parent-child connection. So I'm going to select the child ankle, select the parent, which is the knee, press the P key, select the knee and the thigh chain, press the P key, and then you can zoom in, select this bone, well, select the child, then I can zoom in, select the parent, and you can see we've got two bones. One is the colt, that probably for the colt we want to reduce that and make this part of the right thigh, right? Now for the pelvis, this can be parented to the spine. We're going to press the P key. And we just continue like that. This is the arrow pocket. So again, we are going to reduce the radius for the arrow pocket, simply because we want to establish the connection, but also we want to have the exact same hierarchy. So arrow and the pelvis, press the P key, and the end joint for the arrow, the mid bone for the arrow, and press the P key. Now I'm going to just spend a little bit of time and go through the hierarchy again. Now, if you continue with this method, then you're hopefully going to end up having everything under only one node. I'm going to pause the video, do this very quick, and we'll be back in a second. All right, I've gone ahead and parented everything, so it's all nice and clean, and JNT spine A01 drives pretty much the entire skeleton. One optional thing you can do, you can go to rigging and create a single joint right at the origin. I'm going to hold down X and just name this JNT underscore root 01. Parent the spine to the root joint. So with that, animators, if they animate from the origin. So this is positioned right at the origin. If you think the look of it is a bit awkward, then you can always go ahead and set it to none. Remember, if you want to export this skeleton as FBX, then you definitely need to bring this draw style back to bone. But for now, I can just set it back to none. We don't see it, but everything is nice and clean, set at the origin for the animators. Now it's time for me to bring the character back, and this step is done. In the next video, we're going to go ahead and bind the skeleton to the geometry. If I bring the whole control setup back, you can see everything is aligned perfectly to the new skeleton that we already have. So I hope you guys enjoyed this tutorial, and see you in the next one.